This is Matt Whitesides, and I'm going to try to give a quick overview for the light controller project for the IT 3001 class. Alright, so I think right now, I have it recording the desktop. So I'm going to try to give a kind of like tutorial-ish kind of thing on how the website works and what the project idea was. Alright. So the the idea was I was going to try to make. Originally, we were going to have the thing just be an executable you run on your computer, and it'd be like Java or C#, and you just click buttons and it automatically update the web server. But we decided it would look cooler and be more practical in a real world sense that if it was just a website. So the idea was we could make like kind of a generic website, or hopefully professional-ish looking website that you could control the light stuff through a web page, which would easily be, put on a phone or anything like that without having to build like separate apps or executables. So, alright, so we can move on. We're going to go to the projects tab here. This kind of gives a description of some of the different things in the light controller. So you might notice there's two separate ones we built. I put built in quotes. The first one being a very kind of simple-ish one, which is just 4 lights that are just RGB that can change colors on their own way. And the second one being kind of an array of individual RGB lights that ended up being a string of 20 that was loaned to by Matthew Dickinson. That's a shout out right there. But we'll start off with the simple one because that one actually ended up maybe being the closest to a complete package. Because I actually had to disassemble it because I ended up needing some of the parts for the second type of light. And I never got great pictures or videos of the case, but I kind of built a makeshift wooden case out of some of the, I had little planks that were for like I don't exactly know what it was for. It was so they were just little wooden planks that you can make kind of stuff with. And I kind of used those and built like a little case around the wiring. And then the lights went on top of the planks. And if you added maybe another layer on top of that, that would actually look like a little bit of a finished kind of product, roughly. But never fully finished it. As you can see, some of the wires are sticking out even in this video down here. But that's just kind of a thing. So this one ended up, this was the one, so, okay, we could try to talk about some of the challenges. This was one of the ones that we thought would be too hard originally to control this string of LEDs accurately, but it ended up being easier to do that than this one, I feel like. So we kind of wasted a little bit of most of the semester on the simpler one, when in reality the seemingly more complex one here was going to be simpler if we had just kind of started with that. But this one actually kind of ended up working fully featured. If you watch this video, you can see that you can control it through the Twitter. Like you can set which Twitter account, as you'll see in a minute actually. But you can set the Twitter account and the weather, and it'll display different things based on that. Or you can custom control it through the custom tab. And so that one ended up working with all of them. But later on, we went through this, we went on to the kind of string of LEDs that were each able to individually control. These actually had really good software I was not aware of that came with them, but like you could download online that already had pre-configured kind of functions and stuff that helped you control each of the individual strings. It was an Adafruit.com product, and they actually made the functions, so had I done maybe a little bit more research, that would have been a better method to go. These I never built a case on. As you can see in this video, that I ended up kind of just having them laid out along, you can't really see it well here. It's kind of like cardboard. It's just laid out and kind of like not nailed. I couldn't permanent. They weren't mine, so I just pinned them into the kind of a cardboard thing to make them all lay out flat. And so ideally you could make it so if you had like a small coffee table or something with some sort of translucent cover, you could just put that under it, or obviously it would come like that, and it would automatically work, and you'd have to have wiring or whatever. We never got Wi-Fi. We never got a Wi-Fi shield for the Arduino, but so everything kind of was tethered by the Ethernet cord, which wouldn't really be that great in real life, but if it works with Ethernet, it'd probably work the same with the Wi-Fi, theoretically. I don't know, but we assume. So that's kind of how the project went. The idea was to have kind of a modular system where you can just easily add different kind of clients in. Like the idea was at first weather, Twitter, and then like individually controlling the lights. I guess if you were proactive, you could maybe go in and make your own using some custom tools. We never got custom tools built into the individual mods like I kind of wanted, like so you could set individual patterns for what the weather would be, like what you can make it do based on what weather temperatures, or what you can make it do based on what Twitter accounts. Right now it only works with like, you'll see in a second. But the idea you could add maybe other modulars in there like Facebook or your phone if you got text or something like that without too much trouble, just kind of because the way you'll see it works in a second is all it is just one file that the Arduino hits the server for, and once it gets that, then it is stoked and does whatever that file tells it to. It's pretty simple. It's just the file correlates to a color, and so like I don't know if I might show it, but for the small one, all it is 3 numbers. One is a color, another one's a delay rate, and the other one's possibly other kind of things it could make it do. Kind of a custom one based on what is sending to it. Alright, so if we move on to the weather controller, the weather controller is using the Simple Weather jQuery API. I'll show it here. Weather client. Yeah. So this is a cool function that automatically taps the Weather Underground kind of client and kind of gets that API into a simple array for you. And here I have it punched in as Columbia Mo, as you can see, but I guess I never added this. Ideally, you'd set your own location, and what I will be showing is you'll have logins. So each person will have an account, and they'll be able to like set their custom stuff for each account. That I don't have fully working yet, but I will show you how that will work because I do have it almost working. And so the weather, it taps this, it gets all that information. It comes back with temperature, region. Really, temperature is the only one the Arduino cares about. So once it gets to temperature, it comes here to a simple switch case statement based on if the temperature range here. So if it's below 32, the light number equals 1, which I have in the light as blue. And then, because I figure below 32 is cold, blue is kind of cold color. And less than 70, I have it as 2 is green. I figured green was kind of like a springish color, but this is pointless. Then it goes to yellowish, orange, and red. And then, so that's basically it. So as you can see, it's really just a simple PHP call. All it does is put the contents in this file, whatever was in there. This function automatically overrides the file. And then this just puts in the light number. So it all figures it out on the server side. And all the Arduino has to do is read in that file. And it's a simple, it's maybe like a few bytes at most long. So it's really simple for the Arduino to read in and uses almost no data. So it's all on the website. That's really where most of the stuff happens. And so that's the weather. Then, so as you can see here, you just load. Oh yeah, when you click this button, it'll load that file. And then when the Arduino is automatically kind of updating when it's connected to an internet. So whenever that Arduino knows that it now wants the weather client, it'll modify it accordingly based on the weather client. The Arduino doesn't actually even need to know like what's the weather, like what's making this happen. All you need to have it know is on this side when you click this. This will make it so it's automatically updating based on the weather. So like that script will automatically refresh kind of on a certain interval after you click this. Otherwise, it'll just continue on with whatever was already happening. Like if we had it on Twitter, that would be what the up file is going to be updating on a regular interval, like always. But once you click this, that'll get rid of that, and it'll start on this for the foreseeable future. Right now, I actually have the regular updating disabled because I'm not really using it, and it's kind of a waste of stuff. That's not the most ideal way to, I am sure, make that happen, but I couldn't think of a simpler other way, and that seemed pretty simple. It just making that PHP script kind of refresh on regular intervals, but not too bad. Alright, we move on to Twitter. This one's actually kind of the more interesting one, I thought, because it took a while. You would think all you would need to do to get Twitter client information, since it's all publicly available anyway, is just hit Twitter with a GET request and it'll automatically send back whatever you asked for. That's how it used to work, apparently. Now, that's not how it works. Now, you have to do a whole bunch of stuff, and you have to register with Twitter and get a developer key and have them send you information back. You need like 4 different keys. I'll show you. I'm gonna click them, and I have it set for my account, which is MattSide734. In real life, it wouldn't really be the most practical thing if you just had your light show when you tweeted stuff, but that's how this works right now. You could set it for anybody else's account, but that would only be one person. So in the future, a way to update it might be multiple people getting, like every time you get a new tweet, but that might be like every few seconds, and that's pointless maybe in real life, but we'll see. So Twitter here, this is just kind of the view. The magic is in all of this junk. This is a quick tutorial on how to get Twitter JSON back or whatever. This is a key you'll get back from Twitter when you register for your account. They'll give you back these 2 keys. These are your account keys, and you have a public one, which is, I guess, what's sent through the GET request, and then a secret one, which is only sent once, I assume, not every time, but after it's authenticated once, you're okay. But you still need it, like every initial request. I'm not exactly sure how that works. And then it's the same again for your individual applications. So like if you had multiple applications that you registered with Twitter, you could have more of these keys, but you just have one for your account. I guess that's what the difference between these are. So you have these 4 keys that are craziness. And then I have it set so the host is api.twitter.com, then methods get, and these are just going to be concatenated onto it when we're sending this to the Twitter through a function I got somewhere. We'll get there. And then here is the the Twitter uses this OAuth client, and you need to send it very specific stuff, I found. You need to send it something called your OAuth customer key. These are all gotten, like these names are all gotten from the Twitter API, but you need to send it these things. Good guy. And you need to send it these specific things, an array of these specific things, through this OAuth array map. And this, I'm not exactly sure what this does. This is what I got from a tutorial somewhere else. I combined like 3 different tutorials and it was magical when I got it to work. So this puts these 2 things in an array, and then it merges these 2 arrays based on the URLs that are up here, and then you get this final array, or well, you have these final arrays, and then you get this. I'm showing out. I don't even know what I did anymore. Well, my impression is you send all that through this post. Oh, I got it. This is sent to OAuth. I remember now. And then that sends back this key. Yeah, that sends back this signature. And then once you have that, then you can send your GET request to Twitter down here. And wow. Get that to Twitter. Use curl to send information over the PHP. And then that comes back. Oh, here we go. Yes. You send it using curl. Okay, that's what I remember now. You send it using curl to get the information, and it sends back, finally, hopefully, if everything authenticates correctly and no errors are appeared, the feed array. And then that you can translate into JSON. And once you have that, you can decode it. And once you have JSON decoded, then you have a sweet object. And then once you have that object, you can call it like any object in PHP with the standard object name. Then you can look this up in the API, but it tells you what information is sent back. There's a bunch. So we got the user and the name. And here, these are the text created at, all that stuff. Only the time, created at time, is the only thing that's useful to the Arduino. And that puts it in the file. Alright. That was hard. It took me days to get this to work. And I tried at least 4 or 5 different methods. This was the only one I somehow got to work. I'm still not even 100% sure. I copy and pasted multiple tutorials together to do it.
Alright, me and Matt chose to do a project about a LED light that changes colors. We chose that project because we thought it was cool and interesting, and we thought we might actually be able to complete it. It was challenging, mainly because of the outdated references on the Arduino site. They would have information that was outdated on there. For example, on the start, getting the IP address for the Arduino, they still had a version of it where it did not have DNS. And it made it pretty difficult to find relevant functions to help us set it up.
But that's how Twitter API works. So you click this button, then it loads the information into the file, and the Arduino reads that, and magic happens. The light turns on different colors. Almost not worth it, honestly. This custom function is saying I didn't have built up as much as I'd like, but it just has all the. This is just for the standard single LED array. Or not single LED, but single controllable LEDs, not the multiple ones. So here you can just set the different colors. These are all the realistic colors you could have. You could have variations on these colors, but it'd be useless. I think even the multiple LED array accepts kind of like 24-bit color, but really it's maybe 8-ish bits that can actually be seen or even deciphered. So it's all kind of translated down. Neither one of the LEDs are like the most fantastic color representations in the world. you can kind of tell, I didn't take any pictures of it, but you can kind of white balance the LEDs, and even when they're trying to display white, it's a little purplish tinted, so that's how you can kind of tell they're not perfect. And you can set a delay in seconds here. As I kind of discovered, anything... What is going on? Yeah, I'm recording, it didn't like that. And anything over a 1 second delay is kind of dumb. Alright, moving on to the pixel array. This was the cooler one. This, I have some sample code of my code that they downloaded, or that I uploaded, whatever. And so all you need is, if you have the array, I should put a link to where to buy the things. If you have the array and the Arduino and the Ethernet shield or Wi-Fi shield, and you know how to connect all those, there's tutorials online for that, obviously, wherever you bought those from. Then all you need to do is just download these codes and plug them into your Arduino API, or whatever that's called. Your Arduino... I don't know what it's called. Your compiler, I guess. And yeah, once you compile that, then you should be good to go with this website. But as I don't have accounts working right yet, if two people tried to do it, they just mess each other's stuff up all the time. But I will have accounts working soon. Maybe. Yeah, but this kind of gives information on how you should set up your square pixel array, if that's how you want that to work. The square pixel array does more with weather. If you set the weather to it, it'll display the weather based on what the weather is currently. Like, I think I showed a video, and it's like 80 degrees or something. It will show like 80, and then you can look at what the weather is. But the Twitter, it kind of just does a string. Like, it'll do like a weird snake pattern I made. I thought it was kind of cool, so I was like, hey, that should be the Twitter thing. And it'll make a weird snake pattern. It's basically the same thing as the standard LEDs, but it does different stuff. So that's kind of the idea. And here's how I kind of made a little graph of how I set the pixel grid up if you wanted to try to make it on your own. Just basically the 0th position right here, then 1, 2, 3, 4, and kind of this snake-like pattern. And it ends up looking, I mean, it doesn't look exactly like this. It looks more square in real life. But, so yeah. And so that's cool. And that is about it for the tutorial. It was made by me, Matthew Whitesides. I did the website design and some of the coding for the Arduino, and Adam Forbes, who did the hardware stuff. Alright, good luck.